Hello, I'm Jacob. Right. Yeah, my name's Jacob. I live in Wellington, New Zealand. I am married with one cat and no gophers. I've got a broad variety of experience in the software industry. I've worked in embedded system development and real-time systems. I've been in SCADA engineering, some 2D graphics, and also telecommunications and network engineering, so a fairly broad base of experience there. And in my home time, I like to write audio music software. So about 20 years ago when I was a student, and it's quite some time back, I wrote a piece of software called the Carbon Looper. So this is a fairly conventional software sampler and looper. And as you can see on here, these red boxes are where I'm playing my guitar. The green ones are where the software is playing. My audio loops back, and I build up a song basically playing a bit of rhythm and then melody and then harmony and so forth. This software, as you can see, is quite dated. The source base is going on 15 years old now. It's implemented in C and C++, and I don't really have a future for it. So I've wanted to re-implement that. I want to do that on modern technologies, and I also want to target the web. That meaning I can actually build the software in such a way that I can put it on a server, share a URL, and say, people, just go and have a look at it, nothing to install, just have a play. And it's a home project, so unconstrained by time and deadlines and so forth. So my long-term ambition for this work is something like a piece of software called Reactor. This is an audio DSP workspace where you can just basically put down a set of processing units, wire them all up, and then basically build your own synthesizer. Right, so why do I want to use Golang? The reason that I'm attracted to Golang is that it has a lot of compile targets. So I can build the software down to native code, in which it will run in a very efficient way and get that hard real-time performance. Time deadlines down to about 1 to 2 milliseconds that you need for a real musical instrument. I can also build the software into JavaScript and run it directly in the web browser. So the performance isn't as good, but what I can do is actually just share that. You know, here's a link, load the software, have a play with it. Right. So the first thing I need to build is my synthesizer. So, by the way, when I draw diagrams for these slides, I've decided that if you can't do it in ASCII text art, it's too much for presentation. And also, if you put these dots on the sides, it looks like it came out of a dot matrix printer from the 80s. So it's a really good way to do your diagrams. So, just going back there, this is a minimum viable synthesizer. There's an oscillator which makes the tone, an envelope generator which shapes the noise. So as you press a key, it rapidly rises up to its maximum volume and then drops off, and then a gain which multiplies these things together. Right, so now I've got a dilemma. Because I want to build the software for both native platforms, Windows and Linux, and I also want to build it for JavaScript, I need some way that I can build a user interface which will work on all of those platforms. So it seems like a natural thing to do it in a sort of browser-based, HTML, SVG kind of graphics. If it's a native application, how do I do it? So here's my answer. Stream the DOM. So in the simplest possible way, we have a server which is running the native application and talking to the audio hardware. We have a web browser running on the other side. They are connected by a WebSocket. We pass user interface events such as mouse clicks and key presses and so forth down one side, and we pass DOM patches which update the user interface down the other. So let's see it in action. Right, so here's our synthesizer. We can build our processing units, we can wire them up, we can drop things off and so forth, and then we can press the keys. So just to prove this is a native app, I've got a little keyboard here, and if we press the keys here, we can see that that's running and that those user interface events are coming through, and those keys are lighting up. So just to make it a little bit more clear what's going on here, if I open a secondary window, and start moving these items after I refresh it, we can see that those are following along. If I open a JavaScript console, I've just got a little bit of logging going on here, and you can see as I move the mouse around, I'm sending mouse events down to the server, and I'm getting these patches back. So in this case, these patches are empty but, because there's no user interface change, but they will contain instructions which update the user interface. So let's just have a look at how the code looks. It's a very React-like interface. So basically we have a structure which implements a render method. It returns something I'm calling a VDOM element, and that can then just basically build up the user interface components. So in this case, it's just an example of a to-do, the classic React to-do application. It's building up a div, an input tag, and then registering an event handler, which will then be able to have notification of those change and mouse click events and things like that. So this approach does have a few limitations. I have limited event handling. We can't really do propagation or event bubbling or anything like that. It's very much one event and then one response from the server. No browser-side API calls, so I can't be sort of going from the browser up to the internet or anything like that. It's not for that kind of application. No async state updates, and also can be potentially a little bit slow because it's running over a WebSocket, but that's not the only option for communication. So, thank you very much. I hope that's been useful. Have a look at it on GitHub, and I'll be around the rest of the day, so have a chat.